Okay, so like picture this. You're at the pump, right, filling up your tank,
Mhm.
and it hits you, that feeling, the never-ending saga of fuel costs.
Yeah.
Or maybe it's when you're looking at that monthly car payment, and you're just like, "Ugh, really?" And wouldn't it be amazing if there was a way to make cars lighter, cheaper,
Yeah.
and maybe even a little easier on the planet while we're at it?
Hmm.
Well, that's exactly what we're digging into today. We're talking about some really cool news coming out of the automotive world, specifically how some companies are using plastics and composites in some seriously innovative ways, like head-turning stuff.
Yeah.
Get this. Both the Society of Plastics Engineers, SPE for those in the know, and the American Composites Manufacturers Association, ACMA, they both just gave out awards for a groundbreaking new part.
Okay.
And the best part, it all comes down to, you guessed it, making cars lighter and less expensive.
It's pretty exciting.
So buckle up as we unpack why these awards actually matter, what this tech is, and what it could mean for the future of how cars are made, and maybe even, just maybe, how much we end up shelling out to own one.
Yeah.
And this isn't just some random innovation. We're talking about some heavy hitters here. We've got Braskem, a global leader in the plastics world, teaming up with this cutting-edge startup called WEAV3D. And to give this whole partnership like some serious academic weight, they got Clemson University's Composite Center involved as well.
Oh, wow. You see, what's so fascinating here is that the auto industry, it's always on this quest, right, for lighter materials. It's this constant balancing act. Lighter means you get better fuel efficiency, which obviously translates to lower emissions, things we desperately need right now.
Absolutely.
But, and this is the tricky part, traditionally, achieving that lightweight design, it often meant sacrifices, usually in terms of cost or the actual strength of the materials themselves. And then on top of that, you've got this massive challenge of figuring out, well, how do you even manufacture these new materials at scale?
Right.
It's a whole other beast entirely.
Right. So it's like trying to juggle like all these different priorities at the same time.
Yeah.
Cost, weight, strength, and then actually being able to make the things. Not an easy feat.
Yeah.
So how does this new tech manage to, as you said, tackle all of these challenges kind of at the same time? What's so special about it?
Well, the awards, they focused on a redesigned component, something actually pretty standard in every car, the door. And what's remarkable is that by using these really innovative materials and some really cool design techniques, they've managed to create a car door that's, well, it's significantly lighter than traditional ones. And when we say significant, I mean a whopping 23% lighter.
Wow, 23%. That's way more than I was expecting. But like, does that actually translate to a noticeable difference for drivers? Like, are people actually going to feel that in their gas mileage or how the car handles? Or is this more of a kind of behind the scenes improvement?
That's a great question, and it gets to the heart of why this is such a big deal. You see, a 23% weight reduction, it might not sound like much on its own, in isolation, but when you scale that up, and we're talking millions of cars all shedding that much weight, the impact on fuel consumption, it becomes substantial. I mean, we're talking about potentially saving billions of gallons of fuel, billions over the life cycle of these vehicles.
Wow.
And the environmental benefits in terms of reduced emissions,
Yeah.
equally significant.
Okay, so that's a huge win for the environment. But what about my wallet? You mentioned this tech could impact cost as well, right?
Absolutely. And this is where things get really, really exciting, especially from a manufacturing standpoint. This new approach, it isn't just about making these cars lighter, it's about making them way more affordable to produce as well. And the research actually highlighted a staggering cost reduction of 50% compared to traditional manufacturing methods,
Right.
at least for this specific part.
Hold on, 50%. Now that's what I call a game changer. But before we get too carried away celebrating here, let's dig into exactly how they're achieving these results. What are thermoplastics? And what role do they play in all of this?
So thermoplastics, they're a type of plastic, right? But what makes them unique is that you can melt them and reshape them, like multiple times.
Oh, really?
Yeah, unlike some plastics that once they're solid, that's it, they're done. This makes them like incredibly versatile for manufacturing, especially for, complex shapes like you find in car parts. And what makes them so advantageous here specifically is their strength to weight ratio.
Okay.
They're surprisingly strong for how lightweight they are, which means engineers can use less material overall without compromising, on the structural integrity of the part.
So by using thermoplastics, they're essentially killing two birds with one stone. They're getting lighter weight and lower production costs at the same time.
Yeah, exactly.
And It almost sounds too good to be true.
Right. And it gets even better. They've also managed to achieve a significant reduction in waste with this technology.
Oh, wow.
We're talking about over 60% less waste compared to, how they make conventional car doors.
60%. That's
Yeah.
huge.
Yeah. It's massive, not just, from an environmental perspective, which is obviously huge,
Right.
but also from a cost-saving angle. Less waste, it means less material used overall, and that translates to even more savings for the manufacturers and, hey, potentially lower prices for us down the line.
That's a triple win in my book.
Ugh.
Less waste, lower costs, and lighter, more fuel-efficient cars.
Yeah.
It sounds like everyone wins in this scenario.
Yeah.
But let's shift gears for a moment. Let's talk about the recognition that this innovation is getting. I mean, it's one thing for a company to toot its own horn, right? Talk about how great their technology is. But it's another thing entirely to be recognized by actual industry leaders.
Mhm.
So what are these awards from SPE and ACMA? What do they really tell us about the potential impact of this technology?
Right. These aren't just participation trophies,
Right.
The Society of Plastics Engineers and the American Composites Manufacturers Association, these are the gold standard. When it comes to recognizing real innovation in materials and manufacturing,
Okay.
these awards, they're judged by panels of straight up experts, people who've seen it all. And for them to single out this technology,
Yeah.
that speaks volumes. It means they see this as a game changer, a potential disruptor. And in the automotive industry, no less.
So it's not just hype, it's actual validation from the people who really, really know their stuff. And speaking of hype, I remember reading a quote from I think it was one of the researchers that really stuck with me. They said, and I quote, "This technology could unlock new opportunities for the cost-effective replacement of sheet metal structures with thermoplastics throughout the vehicle." That's a pretty bold statement.
Yeah.
Are they suggesting that we could see entire cars made primarily of these advanced plastics sometime in the future?
That quote, it really captures, I think, the excitement around all of this. And while it's probably a bit premature to say that, traditional materials like steel and aluminum are going to be completely replaced,
Right.
this innovation, it definitely opens up a whole world of possibilities.
Yeah.
Think about it. Fenders, hoods, even structural components, all potentially lighter, cheaper, and more sustainable thanks to thermoplastics. It could fundamentally change, how cars are designed and manufactured in the years to come.
This is where it gets really exciting for me. Imagining the car of the future and how this technology could completely reshape what's under the hood, so to speak.
Right.
But and I think this is important. We've talked a lot about the upsides, the benefits, but no technology is perfect, right?
Right.
So what are some of the potential downsides or hurdles that still need to be addressed with this?
You're absolutely right to bring that up. It's important to be, level-headed. And
Yeah.
while the potential benefits are pretty hard to ignore, it is still relatively early days.
Right.
Scalability is always a challenge with any new manufacturing process, right?
Right.
Can they actually ramp up production to meet the demands of, let's be real, the massive automotive industry without sacrificing quality or cost effectiveness? That's something that, remains to be seen.
And I imagine there are other questions as well. What about the long-term durability of these materials?
Yeah.
Cars, they're exposed to all sorts of things. Extreme temperatures, UV radiation,
Yeah.
Just wear and tear from daily use.
Sure.
How will these thermoplastic components hold up over time compared to, what we're used to, the traditional materials?
Exactly. And those are all valid concerns that, researchers and manufacturers are going to have to address. I mean, there are also questions about how these new materials will interact with existing, manufacturing processes and how readily they can actually be integrated into existing supply chains.
Oh, right, yeah.
And
Right.
then there's the question of repairability. Can these thermoplastic parts be easily repaired, replaced if there's an accident? Or are we going to need specialized equipment and expertise to deal with them?
It seems like there are still a lot of unknowns, a lot of questions that need answers, but the potential benefits are so significant, so big that it's hard not to at least be a little excited about the possibilities.
I agree.
What do you think, listener? Are you as intrigued by this technology as we are? It really does get the wheels turning. And it's not even just about the tech itself, right? It's about what it represents. Like a potential fundamental shift in how we even think about car manufacturing.
Yeah.
and sustainability, really.
Yeah, precisely.
Mhm.
This is so much bigger than just like swapping out one material for another.
Right.
It's about like challenging these assumptions we have, pushing the boundaries of what's actually possible.
Yeah.
And if this technology, if it delivers on even half of its promise, it could it have these like ripple effects throughout the entire industry. I mean, from design and engineering to manufacturing and even like consumer behavior.
So what you're saying is this isn't just like a cool innovation that exists in a vacuum.
Yeah.
It has the potential to trigger all these changes that could like completely transform how we think about cars.
Exactly. Imagine just imagine a future where lighter cars, where that's just like the norm,
Yeah.
leading to huge reductions in fuel consumption emission. Imagine cars becoming way more affordable to actually manufacture, which would, ideally make them more accessible to a wider range of people.
Right. Yeah.
And imagine like a manufacturing process that's significantly less wasteful, which, obviously reduces our environmental footprint. That's the kind of future this technology, it hints at.
Wow. When you put it like that, it really does paint this like this compelling picture of what the future could look like. Okay, so before we wrap up here, let's recap. Let's recap what we talked about today.
Sure.
We've been talking about this really groundbreaking approach to making cars,
Yeah.
using these advanced plastics, these composites, thermoplastics specifically. And these materials, they're lighter, they're stronger, and they're way more cost effective than traditional materials.
Yeah.
And on top of all of that, they can be manufactured with way less waste.
Yeah, and we've seen, this isn't just theoretical. The fact that this technology is already winning awards from, like, let's be real, these are prestigious organizations, SPE, ACMA. That tells us that the folks who really know their stuff, they're taking notice. This isn't, some marketing gimmick. This is a real, genuine breakthrough.
Yeah.
And it's turning heads.
So the next time that you see, a car commercial and they're going on and on about, fuel efficiency, how eco-friendly their cars are, remember this conversation, because there's a good chance that innovations like the one we talk about today are playing a role, behind the scenes in making that happen.
Absolutely. And next time you see a car out in the wild, just take a moment and think about, what's possible. Could that car door be made out of thermoplastic?
Mhm.
What about the hood or even parts of the frame? The car of the future, I mean, on the surface it might look pretty similar to the cars we have today, right?
Right.
But what's going on underneath, that could be radically different.
It's a great reminder that innovation, it often happens like incrementally,
Yeah.
in ways that we don't always see or notice right away. But those seemingly small advancements, those can have huge impacts down the line.
This has been a fascinating deep dive. I really enjoyed kind of digging into this with you.
Me too.
And to our listeners, thanks for coming along for the ride. Until next time.